Hello. We are going to look at multiplying monomials. From the examples that we're going to see, we are going to see a lot of those properties of exponents, specifically the product of powers property, where the base is the same, and so we just add those exponents. So that's a key thing we want to remember with the examples that we're going to see is multiplying powers of the same base. We're going to add those exponents. Any number to the first power is equal to itself. So 9 to the first power is just equal to 9. So let's take a look at an example of this. So we're looking at this question and it says to simplify and express your answer using positive exponents. Okay, so that means that we don't want a negative exponent. We want to fix it if it's a negative exponent. So for this question, we have 6k times 7k. So in order to simplify, we could actually pull these numbers, these coefficients, off of the variables, and we could say 6 times 7, and then that would be multiplied by k times k, because each one of them have their own variable. So what this is we are grouping the coefficients and the exponents. So grouping them together. And variables. And then what we could do is we could say, okay, 6 times 7 is going to give us 42. And then k times k, we can actually rewrite that. Even though there's not an exponent written with each of these variables, we know that it has a 1. It's an exponent of 1. It's just equal to itself. So if we have that, the bases are the same. And this is where we're going to see that product of powers property. The base is the same. And so what we are going to do is we're going to take each of these exponents and add them together. So we'd have k to the 1. It would be 1 plus 1 power, which would be the same thing as saying 42 k, and then 1 plus 1 would give us 2. So 40, and erase that. 42k squared. That would be our answer simplified. Since we don't know what k is, we couldn't go any further. Let's look at another one of these. So here we want to simplify. Again, we want to express our answer using positive exponents. But now we have 7w to the 6th power times 4w to the 9th power. So we can, again, group the coefficients and group the variables together. So the coefficients, we could say, and I'll write this over here, 7w to the 6th power times 4w to the 9th. So our coefficients are 7 and 4. So we're going to say 7 times 4. And then our variables are going to be w to the 6th power and w to the 9th power. And since they are the same variable, we can actually write this as w to the 6th, w to the 9th. And then we want to multiply the coefficients. So 7 times 4 is 28. But then what we also want to do is we want to multiply using the product of powers property. So in that case, we're actually going to add the exponents. So we would have 28w to the 6 plus 9 power. And then once we solve that, 6 plus 9 is 15. So we would say that our answer would be 28w to the 15th power. Since we don't know what w is, we would just leave that alone, and this would be our answer for this question. And that's a lot of times where you'll see it say simplify, because you're not going to get a final number. Let's try another one. So again, we're going to simplify, express your answer using positive exponents. We have 10g cubed times 2g. So we want to group those exponents, or I'm sorry, group those variables, group those coefficients together. So 10g cubed times 2g. We would say that our coefficients are 10 and 2. So 10 times 2. And then we would say that our variables are g to the third, and then g, which we know that this could be written as g to the first power. So we would say times g cubed g. And then if we keep going with this, we're going to multiply those coefficients. So 10 times 2 is 20. And then g cubed times g, we can rewrite that by adding those exponents. So g to the 3 for this exponent. And then this one we said was 1. So 3 plus 1 power, which would give us an answer of 20g to the 4th power. All right. Look at this one. We've got 6q times 6q, or I'm sorry, 6q to the 6th power times 6q to the 45th power. Now these numbers are a little bit, these exponents are a little bit higher, but we're going to solve it the same way that we did before, and we just want to express our answer as a positive exponent. So we can group our coefficients and group our variables together. So 6 and 6 are the coefficients, so 6 times 6. And then the variables are q to the 6th power, and then q to the 45th power. And once we start solving, we're going to multiply those coefficients together. 6 times 6 is 36. And then q, I'll erase that. We would say q, we would take these exponents here, 6 and 45, and we would just add them according to the property of exponents. The base q is the same, so 6 plus 45. And then this is going to give us a final answer of 36q. And then 6 plus 45 is going to be 51. So 36q to the 51st power. All right, we'll keep moving with this one. Let's look at this question here. We have 5r times 6r to the 8th power. And with this one too, the parentheses are there. It's really the same thing that we've seen before. It just lets us know that those are grouped together and we are multiplying. So there's not really anything different that you're going to do with this one besides the math that's involved. So we would have 5r, and I'll keep the parentheses, 6r to the 8th power. We know that even though it's not written down, we know that this has an exponent of 1. So we're going to group these coefficients together, and we're going to say 5 and 6, 5 times 6. And then we would say that r to the 1st and r to the 8th, those are our variables. We can write this like this. And then we would just solve. We would just multiply our coefficients. 5 times 6 is 30. And then we could write this as r. We would add these exponents together because the base is the same. So 1 plus 8. And that would give us an answer of 30 r to the 9th power. So even though we had those parentheses and it was set up a little bit differently than what we've seen in the last couple of examples, we would still solve it the same way that we have been, by grouping those coefficients, grouping those variables, multiplying, and then using that product of powers property with exponents to add those exponents together and to get one exponent, one positive exponent at the end. Let's look at this one. This one's a little bit, there's a little bit more to this one, but it's the same. It really is the same steps that are involved. So when we look at this one, we write 5p cubed q to the 6th times 8p to the 5th q to the 4th. We are going to group those coefficients. So 5 and 8, those are the only coefficients. Even though they're going with both of those variables, those are the coefficients that we're gonna multiply together. 5 times 8. And then what we would do is we're actually going to group these by the variable. So we have a variable of p cubed, and then we also have p to the 5th. So we're gonna separate those from the q. So p cubed, and then p to the 5th. And then we're going to have one more set of grouping. We're going to group the variable of q together. So we would have q to the 6th and q to the 4th. And then we would go through, we would do everything that we had done before, but now we just have an additional variable with that. So 5 times 8 is 40. And we would have p, we could say 3 plus 5. And then we could also write this down here, q, 6 plus 4. And so we would be left with our answer of 40. We would have p, 3 plus 5 is 8. Q, 6 plus 4 is 10. So our answer would be 40, p to the 8th, q to the 10th. And let's look at one more since we tried this more challenging one. This one's also going to be a little bit more challenging, but the same steps are involved as well. So we would have 10 q to the 9th rs times 10 q to the 4th r cubed s squared. So we would go through, we're going to group those coefficients together, group those variables together, 10 times 10. And then we could group the variables. We'd have q to the 9th and q to the 4th. And then we would have another set of groupings. We'd have r. And even though it's not written there, we would know that r is to the 1st power. So r, and then r cubed. And then we, in this case, we're actually gonna have one more set of groups, and I'm gonna change the color for this. And we'd have s, again, it's not written there, but we would know that s is to the 1st power. So s and then s squared. So we go through again. It's just going to be a little bit longer this time, but it's much easier to solve once you've grouped those variables together instead of looking at it up here this way. It may prove to be a little bit easier to separate those variables and have a better look at what's going to be combined with what. Okay, so 10 times 10, we would say that is 100. And then q to the 9th plus 4. And then we'd have r to the first plus 3. And then we would have s to the first plus 2. And we could go through and add all this up, which would give us 100. Q, 9 plus 4 is 13. R, 1 plus 3 is 4. And then S, 1 plus 2 is 3. And even though, I mean, it does look different, it is still, that is going to be how you would simplify this expression by multiplying those monomials together.